representation of simple molecules. Now this Lewis dot structure shows the picture of bonding in molecule and ions in terms of shared pair of electrons and octet rule. So the Lewis dot structure explains the picture of molecules and ions in terms of shared pair of electrons. I will write here shared pair of electrons and octet rule. So Lewis dot structure shows the picture of ions or molecules in terms of shared pair of electrons or octet rule. Although such picture does not explain completely bonding and behavior of molecule, bonding or behavior of the molecules. So these things are not explained by the Lewis dot structure. It helps to understand formation and property of molecules. So Lewis dot structure help us to understand the formation and properties of the molecule. Lewis dot structure help us to understand the formation and properties of the molecule. So there are some steps involved or steps to write Lewis dot structure. Lewis dot structure. There are some steps to write the Lewis dot structure. So we will discuss one by one. So first one is add total number of valence electrons. You are supposed to add the total number of valence electrons. You are supposed to add the total number of valence electron. Second one, write the skeletal structure. Write the skeletal structure. Write this skeletal structure. For example, you are writing the Lewis dot structure for water molecule. So you know, in water molecule there are 3 atoms, 2 hydrogen, 1 oxygen, H2O, 2 hydrogen and 1 oxygen. So you will write first of all the skeletal structure. You know there are 2 hydrogen and 1 oxygen atom. So this is your skeletal structure. The third step is add the electron to complete the octet. You are supposed to add the electrons. Add electrons to complete octet. Now how you will write the number of electrons to complete the octet? So this one is hydrogen, oxygen and hydrogen. So there is single bond between this hydrogen oxygen, and here is also single bond between the hydrogen and oxygen. Valence electron for oxygen are atomic number of oxygen is 8. Electronic configuration will be 2,6. The valence electrons are 6. So here valence electrons you can see one from the oxygen, this one is from the oxygen. So there are 2 valence electrons from the oxygen. Now remaining are 4. So I will write 1, 2, 3, 4. So these are the 4 valence electrons from the oxygen. So you have written, now you can see the octet of this oxygen atom is complete. Duplet of this hydrogen atom is complete. Okay. So you have to add the electron to complete the octet. Now fourth step is if octet is not complete, add the multiple bonds. So you have to apply multiple bond if octet is not complete. So multiple bond. When you will add multiple bonds when the octet is not complete. Okay, fifth one, in case of anion, in case of anion, in case of anion, add one negative charge for one electron, add one negative charge, add one electron for one negative charge, add one electron, add one electron for one negative charge, one negative charge. So you have to add one electron for one negative charge in case of anion. Now in case of cations, remove one electron for each positive charge. You are supposed to remove one electron for each positive charge. Okay, now let us continue. Seventh rule. Now in case of polyatomic ions, polyatomic ions mean the ions contain more than one atom. Okay, more than one atom or more than two atom. For example, you have hydrogen diatomic, more than two atom and called as polyatomic. For example, okay, in case of SO4 2 minus, in case of polyatomic ion, what is the concept? In case of polyatomic ions, the central atom will be the atom which is least electronegative. The central atom will be the atom which is least electronegative. In case of SO4 2 minus, here sulfur is less electronegative than the oxygen atom. Therefore, the central atom will be sulfur. So here sulfur is central atom. Sulfur is central atom. SO4 2 minus. In case of NO3 minus, nitrogen is less electronegative than oxygen. Therefore, nitrogen is the central atom here. Okay. In case of polyatomic ions, the central atom will be that atom which is least electronegative, atom. In case of SO4 2 minus, sulfur is less electronegative than the oxygen. Therefore, sulfur is the central atom. In case of NO3 minus, nitrogen is the less electronegative than oxygen. Therefore, nitrogen will be the central atom. Okay. Now, after writing number of electron as shared pair, the remaining electron will be used as either lone pair of electrons, or multiple bonds. What is the eighth step? After writing number of electron as shared pair, remaining electron are used either as multiple bonds or they will be written as lone pair of electrons. Okay, either multiple bonds or as the lone pair of electrons. Now there are some examples of Lewis dot structure for some molecules or ion. Lewis dot structure of some molecules or ions. Now we will see some examples here for writing the Lewis dot structure by using all these steps. In case of hydrogen H2 molecule, now there are two hydrogen atoms. You will write the skeletal structure, you will write the valence electron. Now these two electrons will form a bond, a single bond between two hydrogen atoms. So this is the Lewis dot structure, and this is the overall structure of the hydrogen molecule. Second example is oxygen. Now you can see here there are two oxygen atoms, so you will write the skeletal structure of the oxygen. Now valence electron of oxygen are each oxygen atom is 6. Okay, valence electron in case of oxygen are 6. Now I will write here there is valency of oxygen is 2. So you can see here there are 4 electrons between two oxygen atoms. Two electrons are coming from this oxygen, and these 2 electrons are coming from this oxygen atom. Now the valence electron of each oxygen is written, that is 2. Now remaining electrons will be written like this. Okay, now the valence electron of each oxygen are 1 2 3 4 5 6. Now in case of this oxygen 1 2 3 4 5 6, so both the oxygens are now having valence electron 6. Now there are 4 electrons between two oxygen atoms, therefore the number of bond between these two oxygen will be 2. Single bond, and this oxygen. The remaining electron will be written as it is. Okay, this is the oxygen, O2. Now in case of ozone, that is O3. Now write the skeletal structure of ozone, O3. You can see here 3 oxygen atom, 1 2 3. The valence electron of each oxygen atoms are 6. Okay, the valence electron of oxygen atoms are 6. Now see how the structure of this O3 is. Okay, now between these two oxygen atoms there are 1 2 3 4 electron, means there is double bond. Between these two oxygen 1 2 there are 2 electrons. Okay, now the valence electron, you are supposed to count the valence electron in case of each oxygen. So here you can see the valence electrons are 1 2, remaining will be 3 4 5 6. Okay, here the valence electron of these oxygen are 1 2 3 4, 1 2 3. Right, 1 2. Okay, now 1 2. In case of this oxygen 1 2 3 4 5 6, and this will be the negative charge due to extra electron. In case of anion, you have seen that in case of anion you are supposed to write negative charge for each electron. Here we will apply the positive charge, because the non-bonding electrons or lone pair of electrons of this oxygen atoms are involved in bonding with this oxygen atom, therefore it will acquire the positive charge, means this oxygen is electron deficient. Now count the total number of bonds for this oxygen atom, 1 2 and 3. Usually the oxygen forms 2 bonds, but this oxygen is having 3 bonds, therefore it will acquire positive charge. It will acquire the positive charge. Now due to the extra electrons, this oxygen will be having negative charge. Okay, negative charge. Okay, I will write like this, or you can write with the full bonds like this. Okay, oxygen, double bond. This is single bond. This oxygen carries negative charge. This oxygen carries positive charge. This oxygen is having 2 lone pair of electrons, 1 2. This oxygen is having only 1 lone pair of electron. This oxygen will be having 3 lone pair of electrons. So this negative charge, this is positive charge. Okay, negative positive, that will be equal to 0. That will be no charge. O3. Now carbonate, CO3 2 minus C. CO3 2 minus. Now this is the polyatomic ion. Least electronegative atom will be the central atom. Now see the structure of this carbonate. Write the skeletal structure of this carbonate. You can see here one carbon and 3 oxygen. So you will write like this: one carbon, 3 oxygen. Now there is double bond between this carbon oxygen, and there is single bond between this carbon and single bond between this carbon oxygen. Now this carbon will be having 2 lone pair of electrons, and this oxygen will be having 2 lone pair of electron, and these 2 remaining oxygen will be having 3 lone pair of electron. Due to one extra pair of electron, there will be extra one electron, there will be one negative charge for this oxygen and one negative charge for this oxygen. So overall charge on the ion will be 2 minus. You will write like this, or write carbon double bond oxygen, single bond oxygen, negative charge, single bond oxygen, negative charge. This oxygen will be having 2 lone pair of electron, this oxygen will be having 3 lone pair of electrons. Okay, now this one is negative, this one is negative, so overall the ion is getting 2 negative charges. So here, or you, instead of writing like this, you can cut from here and you can draw a bracket and superscript 2 minus. Okay, write it like this: 2 minus charges. So these are the examples of Lewis dot structure of some molecules or ions. Okay, remaining part we will continue in next lecture, inshallah. Okay.